type of thing, maybe we're kind of combining a couple topics here, okay? So we're taking identity stuff, although it's not going to be, I don't think this is as challenging as identities, because you're actually working with the unit circle, which you'll have on the test, okay? So I don't think it's as challenging. But I do think that it is going to be something where we're using that, the unit circles, and the verifying identity concept, okay? And we'll go from there. So if I was getting sine of x by itself, okay? Give me a thought real quick. I saw a lot of you with the answer. What would be something that we start with? Just add 1, right? We're going to add 1. So when we come here, we're going to add 1 either side, right? So we get 2 sine of x equals 1. And then again, we're trying to get sine of x by itself, right? And we do that by doing what? Dividing by 2, right? So what we get now is sine of x equals 1 over 2. So this is kind of the foundational piece with where we're going to head today. Is there anyone that struggled with how to get here? Okay. Now some of you try to divide by sign, right? Can I do that? We can't divide by sign, right? There's no way that we can do that. So on these problems, what we're expecting is for you to ask the question, what can I plug into x on my unit circle? Or what is the angle that is associated to where sine is 1/2 on the unit circle? Okay. Now some of you have a unit circle around. Brad, did you get one? Karis, did you get one? Perfect. I think they're underneath the Michigan flag, underneath the notes. If you want an extra one, or if you're trying to get another unit circle for today, you may need it. So if you want to get one of those, you can. If you've got one in your notes, or if you're okay with that, that's fine as well. Okay? I don't know how many there are back there, but I think there will be enough. Cool. Or if you want to pull up your Mac, you could also do that as well. So the question we have is, where is sine going to be 1/2? And 5 pi over 6. So there's 2 of them, right? So we have this here. This would be pi over 6 and 5 pi over 6. Now here we go. I've got 3 tickets to someone who can tell me why. I thought that sine had to be in range. Do you remember this? Like back in the day, we said that it had to be in range. But it was only for something specific. Why could we go out of range for this one? What makes this one different than the last one? You got anything, Kennedy?
This one's regular sine. It's not inverse.
Correct. We're not doing an inverse, right? We don't see that sine to the -1, and so they're put at the range out. This is going to be completely different. So because of that, we just say, where on the unit circle is x going to have sine, or what location is sine going to be 1/2? Cool? Questions on this? Kennedy, good work there. Nicely done. Okay, let's look at the next one. These will gradually get harder, I'll be honest with you, okay? These will gradually get harder. Now, does everyone have notes on there? Is there anyone that doesn't? Okay, so when I say the example, these are a little small. I'm guessing everyone has them around so you can kind of see it, right? So you kind of look on with me. Okay, so example 2 is where we're at. Is that in the notes too? Example 2? Excellent. So with this one, it starts becoming just a little bit tougher. Now, if you think of sine as simply x, it doesn't become as difficult. Okay, so if we just think of sine as we're just going to combine them together and we're just going to solve it, it makes it much more easy. It's easier than if you think of it the other way. So if I say this, sine of x plus square roots of 2 equals negative sine of x, what do we want to do? Sign on the same side, right? Just like we would in a regular equation. And how would we do that? Yeah, so we could say add sine x on both sides. Okay. This is something, too, I noticed we talked about fundamentals in this class. Just some of you were even admitting in the last class, hey, these fundamentals I'm still trying to work on. We're trying to get through. And I 100% understand that. So I just want to make sure we get this. Sine x plus sine x would be what? 2 sine x. It would not be sine squared, right? When would it be sine squared?
Sine x times sine x.
Good, Graham. It's when it's multiplied, right? When we multiply that. So because we simply add it, we would get 2 sine of x equals, and what do we take to the other side?
Negative square root of 2.
Yeah, so we're going to subtract, just so you can see this here. Subtract square roots of 2 here. We'll do it to both sides. So this is equal to negative square roots of 2. Good. Okay, so what do I do now with the 2 sine of x equals square roots of 2 to be able to get sine of x by itself? Kenny?
Divide by 2.
I like it. Good. Okay. Am I going too quick right now? Am I good so far? Just looking at faces. So if you're confused, let me know. So we're looking for where is sine of x equal to negative root 2 over 2. Okay. All right. Someone at Diego's table, Brad or Karis, any of y'all three, or all three of you in that way, where's sine of x negative square roots of 2 over 2? Good. Good. So 5 pi over 4 and 7 pi over 4 would be the 2 answers that we would state and find. Okay. I think we've done something similar to this. It's just going a little more difficult because you're actually going to have to solve it now. That's where we're headed. Okay, Josh?
So at the end of that, it says intervals of 0 and 2 pi.
Yeah, this just means that my answers have to be between 0 and 2 pi.
Will ever not be.
Yes. So if I actually, technically on this last one down here, you'll notice, does it say between the interval of 0 to 2 pi? So technically, because of that, we got to think it can also be any of the coterminal angles, right? Now this has got to kind of think outside the box a little bit on this. That technically means that pi over 6 and 5 pi over 6 are not the only answers, right? Because if I took pi over 6 and 5 pi over 6, those are my 2 answers if it was in the interval. But if it was pi over 6 and I was looking at you, Josh, but then I rotated and then I came around, I could keep adding 2 pi because wherever I start is where I would stop if I added 2 pi, right? So what I would need to do with these 2 is actually add what to it? 2 pi. How many times? N times. What does n mean? We don't know. It doesn't matter, right? That's really good, Diego. It wouldn't matter. 100 times, bazillion times, doesn't matter. And what we would state then is, it's just those 2. But then we add 2 pi in to say that it just keeps rotating over and over and over again. Does that make sense?
Are you going to want us to do that on the test?
It's a good question. I want you to be familiar with both. When it comes test time, I'll probably pick one and just say, hey, do it this way. Or I'll be very specific and say, hey, with these ones, this is what I'm looking for. With these ones, this is what you're looking for. So technically for right now, let's just say if it does not have the interval, we're going to add 2 pi into each of them, right? That could change a little bit. We'll talk about that later. But for right now, 2 pi in. And then over here, because it's between 0 and 2 pi, just give me the answers. And you'll be fine on there. Okay? Cool. Questions on that? All right, let's keep going. Okay, we're just repping them out. Again, as we keep going, it's kind of like we're increasing in level from one example to the other. So slow me down if you get to one that you're struggling on. All right, 3 tangent squared x minus 1 equals 0. All right, someone want to just help me out? What would we do?
Add 1.
Good, yeah, let's add 1. All right, go ahead, Diego. What else would we do here?
Divide by 3.
Nice. Again, the goal is to get tangent by itself, right? So we got tangent squared of x equals 1/3. Any other thoughts there?
Square root of the tan squared.
Good. We square root, right? What we do to one side, we give some love to the other. So we get tangent of x is equal to
Square root of 1.
that deserves 2 right there. Yeah, this is a little challenging. What's the square root of 1? On top. Just 1. What's the square root of 3 on the bottom?
Square root of 3.
Root 3. So we just broke it up is all we did. Do we like that square root on the bottom? No. So we do what? Multiply top and bottom by root 3. Good. What does that get us? Root 3 over 3. Nice. So where's tangent of x? Square roots of 3 over 3. All right, here we go. Now, let me backtrack. Is there anyone that struggled with how I got here? All right, I will give 8 tickets for this next question. You ready for this? Here we go. Ready? Oh man, here we are. There's something wrong with what I just put down here. There's something, there's just something wrong. If you could pick out what is wrong and why, I've got 8 tickets for you. Thomas.
Is it the denominator?
No, actually, yeah, the denominator's good, actually. Good thought, though. 8 tickets. It's actually on the unit circle because you do y over x. Does anyone know where it would be on the unit circle?
7, 5, 6.
Yeah, it would actually be pi over 6, right? Because at the 30-degree angle, the tangent is square root of 3 over 30, right? When you do the y over x part. Is everyone clear on that? So technically, pi over 6, so the answer is, yeah, pi over 6 and I think the other one's 7 pi over 6. Those two are where tangent will be positive square root of 3 over 3. But I'm still missing something.
Solve.
Is it now supposed to be tangent?
It is tangent. We're still good because we had tangent. We just solved for tangent right here, right? It's really in this box. That's the hint. Something, or in this circle.
We got to extract the square root.
X.
No?
Find X.
I'll give 12 tickets if you know.
You said it.
Now, this is good. Still, these right here are good. Not SOHCAHTOA. Because we're still using the unit circle. 14 tickets if you know.
Does it have to do with X?
We are solving for x. Kind of.
I gotta set equals 0.
Kind of red.
I gotta set equals
We
0.
have to find
Not
it.
set equal to 0.
That's easier.
You have to convert it to something
It
else.
kind of came. Let me see. Let me do this. Come over here. I know I'm dragging this out. You're probably like, just tell us. This right here, okay, comes back up to here.
Yeah,
That's a good question.
it was supposed to be square.
It's good. Mary Grace? It's a good thought. It's not quite. This right here? I think this is okay because I square rooted a squared, which they can cancel out. We can actually do that with the tangent. That's a good thought, though. It would still be tangent. These are all good thoughts. I love the ideas of this. No, this is still good. This is still good. Emma?
Do you have to do anything to the x when you like square the tangent of square? Is that like
Not for the x, no. That was a good hint. If you were, it was a subtle hint.
Is it supposed to be inverse?
No? You're going to be really angry when I say this. You ready? You ready? Here we go. It's really, you're going to miss it. Plus or minus?
What?
Why? Why is it plus or minus? When I square root a squared, what happens to the other side? Plus or minus. Just take a little note there. That's probably good. Good to have there. Square root a squared, yeah. I almost said 20, and I realized that's probably a little much because someone would like triple their tickets. Some people might. So that when I square root a squared, I get tangent of x equals plus or minus square root of 3 over 3. Right? And that's how we get it. So really, it's not just pi over 6 or 7 pi over 6, it's what?
Line or line, plus or minus.
Yeah, well, it would be any time where this is positive or negative square root of 3 over 3. So it would be pi over 6, 5 pi over 6, which would be 11 pi over 6. That's true. Just go around in the positive direction. So pi over 6, 5 pi over 6, 11 pi over 6, and 7 pi over 6. Because it could be either positive or negative. Thomas?
What is that picture?
Oh, these are all from DragonCon. I don't know why I put pictures up like this. It's just
What
totally
is
random.
that supposed to be? Is that a...
I don't know what that one was. It just looked intriguing. I don't know. I've always been intrigued by DragonCon. I've never been, but I'm always like, I love the costumes and stuff. I just think it's cool. So I just put them on there. Questions on this? Y'all feel okay on that now that I told you? Okay, good, good, good. All right, let's go to the next example here. All right, example 4. Y'all doing okay with me? Okay, good, good, good. Let's move this over on this side. Example 4. Oh man, this is tough. Tough one. Ty?
The plus or minus, it's only plus or minus when it's tangent, or is that on every?
When we square root a squared. Great question. So if something is squared and we square root it, that's just math in general. If I said, oh my, did you see that? this? What's going on? We might need to pray again. All right. We haven't prayed today, have we? That's why. X squared equals 4. How would what could we plug in for x for that to be true?
So if you plug in, you can plug in
2 or negative 2. Do you see that?
Oh, okay.
So this is just a basic example, but if I square rooted, that means x could be either plus or minus 2.
Gotcha.
And that's just a basic example, but that's how we get that there, okay? I need to erase this before chaos comes. There we go. All right, example 4. This is factoring. That's the key, okay? That's the hint. Any thoughts of what we could do here? This looks really, really complicated. And I could see how you could think that, but we've got to do something first. Ty, you got something?
Divide coefficients.
I actually could see that. Could we do this first? Maybe this will help us. Instead of dividing by cotangent within this realm, right, with 5.3 here, let's take cotangent just to the other side right now, okay? And you'll see why that's the case. I'm actually going to give a ticket on that because even though it wasn't right, that's actually good mathematical thought. But for today, we're just going to say, okay, cotangent of x, cosine squared of x, minus 2 cotangent of x equals 0. Okay? All right. I saw some hands out there. You probably have maybe a thought of what we could do next. Here's the key. We're trying to do not exactly like our identities, but similar in terms of some of the processes there. Any thoughts of what we could do, Graham? Could we combine these two? Because they're not alike. Now, if there were, we would do that, but this is not alike to this. Tommy? It's a good thought. I would say if I see this in this instance here, because we're solving, not verifying identities, I would say let's pull out what's in common, which would be what, Emma? Yeah, because a cotangent's in common. You see that there? Let's pull out a cotangent of x to the outside, okay? When I do this, what's left over on this first one? Cosine squared, y'all rocking, minus 2. Why not cotangent?
We already worked it out.
Because we already took out what was in common out there. Okay? We took out what was in common already. Good. Does anyone know what type of factoring by show of hands we call this right here? Mary Grace? Yeah, GCF, greatest common factor. Good. That's exactly right. I wanted my son's name to have the initials of GCF, but it didn't work out with Johnson, so it's all good. We'll roll. Anyone confused on where we're at here? We okay?
I have a question. Why?
Diego?
Okay. Isn't there like two cotangents? So like, why isn't there one left? If you only pull out one, why is there one left?
It's a great question.
It's not
Did y'all hear his question? It's actually a really, really good question. Why is there not another cotangent when I pull one out? Bingo. You're thinking of square. If this was cotangent squared, then we'd have one cotangent left over. The 2, yes, there's 2 cotangents. I hear what you're saying. But when I pull out a cotangent, it would only be then left with minus 2. So the 2 doesn't go away, but the 2 is not necessarily saying that we have cotangent times cotangent.
But
Right?
if it was squared, you still have cotangent.
Bingo. Good. That's actually a really good question, Diego. Did everyone get that? Okay. All right, here we go. 6 tickets now. Feeling it today. Anyone tell me what I would do next to solve? Elijah, did you have something? I love that. Good. And before we do the plus 2, let's backtrack for a second. There's one thing we need to do before we add 2, and Elijah has it. Graham, do you know? Not necessarily, though I hear what you're saying. Here's a question. If I had x plus 1 times x minus 2 equals 0, what would I do to solve for x? Okay, yes, but if it's already factored, I set both of them equal to 0. Remember this? Like basics? So what could I do with each of these? Set them each equal to 0. So I'm going to put this down in another color so you can see it. Cotangent of x equals 0. And then cosine squared of x minus 2 equals 0. Right? Good job, Elijah. You're rocking. And Elijah had it because he now says, okay, he thought, okay, now what would I need to do to get cosine squared x minus 2 equals 0, what would I need to find here? Just add 2, right? Okay. So I get 2 is equal to cosine squared of x equals 2. We square root both sides, good. When I square root both sides, what do I get? Plus or minus. So we get cosine of x is equal to plus or minus the square root of 2. Rocket. Okay? Now there's a problem with that, isn't it? What's the problem? There's none what? It's not on my unit circle, okay? So if it's not on your unit circle, what do we do?
Make it on.
This is really mathematical. Not on unit circle. Just put it there. Just put it there. Right? It's not on my unit circle. Is there another way to do that? Probably. Probably. But I'm just going to say if it's not on the unit circle, just put it there. Your work shows it. Okay? So you're good there. You're Gucci on that right side. All right? Now there is a square root of 2 over 2, right? That's not quite the same thing. It's not the same thing there. All right, what about cotangent of x equals 0? Is there some place where cotangent would be 0?
Yeah.
Yeah, which one would it be there, Josh? Both of them. Both of them, right? Because when we go to pi over 2 and 3 pi over 2, and we do x over y, I think we get 0 on both of them, right? I think we get 0 on both of them. So we would say pi over 2 and 3 pi over 2. Rocky. Very good. Okay, questions on that? I'm assuming that all of these are between the interval of 0 and 2 pi, right? Very good. Yeah, just making sure of that. I'm assuming that. If I did not, if it wasn't stated, then I would need to add what to, I'm going to hold on that thought because I'm about ready to say something wrong and I don't want to confuse you. Just hold on to that thought. If it was sine and cosine, what would we add to it?
Plus 2a.
2 pi n. Exactly, 2 pi n. Good Diego, good Josh. And that's how we would go, okay? Cool, how do we feel on this? All right, I'm just checking on this real fast. Okay, all right, good. All right, so here's what we've got left for today. You ready? I've got, I want to go over these two. And I want to go over, I'm just checking on this. I want to go over example 8, okay? I want to go over 3 more. All right, do you want to just keep trudging through? And then afterwards we'll take a break after these 3? Or do y'all need one now? Just keep rocking? Okay, we're going to go over 3. I want you to know that. And then afterwards we're going to take a breather and we'll go from there, okay? All right, here we go. With these ones, example 5, okay? 2 sine squared of x minus sine of x minus 1 equals 0, okay? All right, thoughts on this one? Okay, yeah, maybe we add 1, we go from there. There's a problem with this, though. There's a sine squared and a sine, right? What method would this look like? Let me flip this here. Okay, GCF would be if all 3 had that in common. That's a good thought. Isn't it the, where it's a 3, we call it trinomial, where we do the A times C method? Remember this? If it's hard to see, what do we put in for sine? X. Good. So this would be what? 2x squared minus x minus 1. All right. What do y'all think so far? Good? Who did that? Grant, you said that was you?
Yeah, I was just making a sound effect though.
Oh.
It had nothing to do with this.
Oh, no, it didn't? If it did, tell me.
I will.
You're probably speaking for a lot of other people too. So
I'm just making sounds.
Yeah, I get it. So what would I do from here? What would be the next step? You do the slip and slide, right? That sounds a lot more fun than A times C. But whatever works for you, right? Check and guess. For me, I always start with putting 2x in for both, right here. And then I say, okay, what is A times C method? Or what's the A times C here? I'll put it right here. A times C is? 2 times negative 1 is? Negative 2. Good. So what 2 numbers multiply give me negative 2, but when added equal negative 1? Negative 2 and plus 1. Good. Is there anything I could take out that's in common with one of these factors?
Could you say that again?
Yeah, absolutely. So the A times C method I always use when A is greater than 1. Okay? I always do A times C is the A, the number in front of x squared, multiplied by C. In this case, that'd be -2, right? So then the question is very similar to regular factoring where 1 is in front. We ask the question, what two numbers multiply get me -2, but when added get me -1? And when I think about that, the only two answers would be -2 and +1. And then so I say, is there anything I could take out of 2x plus 1? There's not, right? That stays the same. Is there anything I could take out of 2x minus 2? A 2, which what would be left over? X minus 1, right? And that would be the factored version right there, right?
Set those equal to 0.
Set them equal to 0. Nice. I've got tickets over here. This is good stuff. Okay. Good. So I set each of them equal to 0, right? Except what do I put in for x? Sine, right? Because that's what we had replaced it with. So we say sine of x minus 1 equals 0. And then 2 sine of x plus 1 equals 0 on the right side. Okay? Elijah, what would I do with this over here? Good. So we're looking at where sine of x is equal to 1. That's one place in there. And then what about this side over on the right part? Good.
Is this still 5?
This is still 5. Yeah, I'm putting it over here because ran out of room here. And then what do I do to get sine of x by itself? Divide by 2. So where is sine of x equal to -1/2? Say that again. 7, is that 7 pi over 6? Good. And what's the second one, Paige? 11 pi over 6. Nice. So that's where sine of x is -1/2. Where is sine of x 1? I think it's there. I think there is one.
Or wait, that would just be like 0 to
Oh,
5.
it's just pi.
Yeah, I think because where sine is 1, right? And I think that location would be at pi over 2. Good. So this location is pi over 2. Okay? Good, good. If this was not in the interval between 0 and 2 pi, what would I need to add to each one of these? 2 pi in, right? Y'all see the difference when I say that there? Cool. All right, 2 more examples. Can y'all hold tight here? Y'all have been rocking.
Can we go
Y'all
tight?
This is good. What's that?
Can we go time?
For breather, you can do it in just a little bit. Is that cool?
Yes.
We'll do that. Yeah, I'll let you go for a second there. Yeah, about 30, 45 hour, you know. All right, let's look at example 6. There's a problem with example 6. And if you could, tell you what, you could tell me the problem and the solution. I got 8 tickets for you.
Oh.
Emma, what do you think?
Sine and cosine.
Okay, do you have the solution for us? It's good. I like the, we do see the problem, right? Does everyone see the problem? Can I factor this? No, because why? There's a sine, there's a cosine, there's something up with that, right? So what could I do for 8 tickets to be able to get them to where they are equal? Diego.
Could you turn sine into something else?
Yes. How?
So equal to what we did last unit.
Go. Yeah. Keep going.
Was it cosecant? Or no?
What are you trying to get it in terms of?
Yeah.
You were rocking. We're trying to get this to match up to cosine, right? How do we do that? Elijah, I saw your hand earlier.
1 minus cosine squared.
Bingo, that's it. Sine squared is the same as what? 1 minus cosine squared. So what we can do is sine squared can literally have 1 minus cosine squared in for sine squared, okay? This board is so low. I don't know. I'm so sorry. I apologize. I feel really offended by this, by the way. Yes, go ahead. You may. Go ahead. All right, questions on that part? So what do we do with 2? We distribute, right? So we get what? 2 minus 2 cosine squared of x, and then we just bring everything else down. Plus 3 cosine of x minus 3 equals 0. What do I do from here? combine like terms. So what would I get? We put it over here. So we get negative 2 cosine squared x plus 3 cosine. And then what's the whole number? Minus 1. Good. Equals 0. Cool. What do I do from here? Factor, right? We could factor it because now we're talking everything's in common, everything's the same. Except this negative 2, I like to make that positive, right? Could I just move everything to the other side? I could, which if I did that, what would happen to all of these signs? They would just all change, right? So just be leery of that. This would be positive if I put it to the other side. This would be negative, and this one would be positive 2. Okay? All right, Diego, I know you asked me earlier, so I'm going to ask you just as a setup. If I were to factor this, what would I put at the beginning?
Cosine.
So much.
Yes, except there's a 2 there, right?
Yes.
So wouldn't we just say 2 cosine, or I'm just going to put 2x in it? X is cosine, right? Okay, 2x. Say again? Three? Oh, we're going to use that here in a second,
I
right?
thought we were doing GCF.
Oh, we can't use GCF because this 1 does not have a cosine.
Oh,
Yeah, Elijah.
If I turn it to -1,
So this is a positive 1, right? Because it was
Oh.
negative. The yellow part that you see here is what I did when I changed all the signs. As long as I do it to every one of them, I can do that. Okay?
then you multiply A times C.
A times C,
C, yeah.
right? So 2 times 1 gets me 2. So what 2 numbers multiplied get me 2, but when added get me negative 3?
-2.
And? Negative 2, negative 1. And is there anything in common in one of the factors? 2, which would change this to x minus 1. This is 2x minus 1. And then therefore what goes in for x?
Cosine.
Cosine, right? So cosine of x minus 1, and then 2 cosine of x minus 1. And there you are. What would I do to then go and solve? Set both of them equal to 0, and then go ahead and solve from there. Okay? All right? Y'all feel okay at this? I'm starting to lose you a little bit. I would lose myself too if I was. This is a lot. Okay? Let's do one more. Could we do it? We'll trudge through one more problem, and then we'll take a breather, and we'll go from there. All right.
What happened at 3 though?
3. This negative 3 right here.
You're on the problem. There's 3 cosine minus 3.
I think the negative 3 was down here. And when we distributed 2 to each of these, we got 2 minus 2 cosine squared. And so when we combined like terms, it was 2 minus 3, which was negative 1. You see that? And then we proceeded from there. Elijah? Got it there? Okay. If you get this one is a little bit difficult. We'll keep repping these out and practicing. Cool? All right, last one. Here we are. By the way, what would I add to this if it was not in between 0 and 2 pi? 2 pi a. Good. Last problem. Here we go. I want to blow this one up just a little bit because this one is one that is tricky. You really want to dial in. If there was one problem, Kennedy came in for the perfect one. Okay? Right here. This one becomes a little tough. Okay. What's different with this one than the last one? There's a t instead of x. Is that relevant? No, not the t and the x. It could be anything, right? Could be my son's middle name, Theta. It does not matter.
3.
Okay? The 3. Okay? The 3. So this 3 right here, okay, is what changes it just slightly. Now, here's the good news. It does not change until the very end. Okay? So solve it the exact same way until the very end. Okay? So let's try it out. Solve it the same way. What would I do? Add 1. Good. Okay? So add 1. So we get 2 cosine of 3t equals 1. What do I do next? Again, save 3t till the end, right? Don't worry about it till the end. Divide by 2. Good, Sophie. A lot of people want to divide by 3 here. Just be careful because sometimes people will, look into doing that. Don't do that yet. Okay, we'll save that to the very end. So then the question is, where is cosine? Again, we save the 3 because it's inside with t. We save that till the end. Where's cosine 1/2? Pi over 3? 5 pi over 3. Okay? Someone out there? Pi over 3 and 5 pi over 3. Good. Okay? Are there any questions on what I've done so far? Feel pretty good, right? Okay. This is where it becomes a little different. We got to bring the 3t in at some point, but we do it at the very end. So if it's inside with cosine, tangent, sine, we do it at the very end. So the question we take is we say 3t, and we set it equal to both of these, and we solve. Okay? So we do that at the very end. So once I'm done, I'm finished. If this is 3t, 2t, whatever, we set that equal to each of these, and we just solve for it. Okay? So it looks like this. We would say 3t is equal to each of these here. And what do I do to get t by itself? Divide by 3, multiply by 1/3. Both are correct. So if I multiply by 1/3, because it's already a fraction over there, what would happen to this part here? Pi over 9. Good. And if I did the same thing over on the other side, we get 5 pi over 9. Okay? Cool, cool. All right, so here's the thing. We're not done yet. I'm sorry. I know you're like, oh, man. Okay. I know you're like, Coach, come on, quick. All right. So here's the thing. What would I add to each of these if I wanted it to be coterminal? Okay, we got to be careful here. Let's backtrack. Why did I add 2 pi over on these? Well, what was with x? 1, right? Like 1x. Okay? What is the period of this, sine and cosine? 2 pi over b. Do you remember this? Meaning it repeats every 2 pi traditionally. So what is the period for this one here? What is b here? 3, right? So the period is what? 2 pi over 3, not just 2 pi. You need me to say that one more time? Yeah. Okay. The period on all the other ones was just x, right? Or it was just 1 was with b. Remember that when we graph these, we found the period, meaning how many times it, like the distance it repeats. We found that by doing 2 pi over b. For the ones that we did earlier, back here, too far, right here, we said that with x, right? What was the period of sine of x equals 1/2? That period was 2 pi over b, which was just 2 pi, right? But when we put a b in this case it's 3, okay? What we have now is a new period. It's not 2 pi over 1, but 2 pi over 3. And so now what am I adding to each of these? 2 pi over 3. Is that all I stop at? 2 pi over 3, and good. And
We don't have to like actually do it.
depends. Did I give you an interval?
No.
Not on this one, okay? Not on this one. Now, what if I said, here's the interval, okay? Find all of them that are in the interval. What you would have to do is, and this is how I traditionally kind of think about it, is I would add 2 pi over 3 to my originals. Got me? Simplify it and go. How many sets of answers do I have? Meaning, this is one set in white, right? How many sets would I have? Well, that 3 gives it away. I would have how many? 3 sets. So I would have to add 2 pi over 3 how many times? Twice, because I already had one, right?
Oh,
Does that make sense? So I would add it 2 more times, getting me 3 sets of answers. Does that make sense? Okay? All right, how we doing? Woo! All right, that was heavy. All right, we are going to break this up, okay? We're going to break this up. If you're struggling, I'm going to give you a 5-minute breather. If you want to get your phone, that's fine. To kind of just chill, that's cool. If you want to go and get something, go to the restroom, that's fine. If you want to get some more soda and wake yourself up a little bit after that riveting lesson, go right ahead, okay? And then we'll come back together, all right? If y'all are struggling, I'll kind of take 5 minutes and even go over some homework ones with you if you need to, okay? Hey, Grant, if you could just not go to the swing set, that'd be great. Cool? But you could be outside, that's fine. I know. What do you think, Elijah? Got lost on that one? Can we do level 5, which is number 8 on your homework? You want to do that together real quick just to see? Put 5 minutes on the clock here. 10:56 we get out at. We got about 30 minutes. That's good. Perfect. Okay, so on number 8, these ones over here are not as bad, right? I don't think they're as bad. The one over here on level 5 becomes a little tougher, right? It does become tough. So let's do this. Let's talk through what you would do with this problem. First off, with this 2x here, I'm going to freeze that, right? I'm going to do that last because it's inside with sign. So what would you do? What would you do next if you were to go forward? Good. So I've got sine squared of 2x equals 1 over 2. What would you do next, Elijah? Yeah, it's a good thought. The 2x, remember, comes last, right? It's the very last thing. You just got to remember it because it's inside the house, right? There you are. Good. And what would happen here? A couple thoughts. So I'd have sine of 2x equals what? Good. And what's the square root of 1? Good. And what's the square root of 2? It's just.
Also 1 over square root.
There you are. Good. Also, when I square root a squared, that's another thing, right? Square root of squared.
Plus minus.
There you are. Good. Plus or minus. Nice. All right. Any other thoughts?
Divide by 10 half.
Well, there's a square root of 2 on the bottom, right? So we haven't gotten the, remember, it's the last thing, right? It's the last thing. So let's do this. Let's find the angles first before we do the 2x, okay? So I've got to get rid of this square root of 2 on the bottom. How do I do that? I can, like, it's called rationalizing by multiplying top and bottom by square root of 2. Okay? So then it would be sine of 2x is equal to plus or minus.
Square root of 2 over 2.
Nice, good. And where are the locations where sine is square root of 2 over 2? Nice.
5 over 4.
Nice.
That's it.
It's plus or minus, right? So it could be negative 2.
Okay. 7 pi over 4 and 5 pi.
Great. All of those right there are all the answers. That's a little weird, isn't it? But you can't have all of them because it was plus or minus. Now what do I do? You've got most of it. You've got most of it. Now, the last part is what? Bring in the 2x, right?
Okay.
So we'll say 2x is equal to pi over 4. Okay, right here. And how do I get x by itself? And you'll do it for each of them, right? You'll do it
Divide by 2.
divide by 2. Same thing as if I divided by 2, it's the same as multiplying by
2 over
1 half, right? 1
1.
half.
Yeah.
So it'd be 1 half on both sides. What would that do with this one? What would that turn into?
It would be x.
X is equal to?
Yeah.
What would this be equal to?
Times pi over 2. Oh, that's a 4.
4, yeah, there you
Pi
are.
over 8.
Nice, pi over 8. So guess what? If I did it for each one of these, what would the denominator change to?
8.
8. Good, because it's the same, right? So we would just change these to 8, 8, 8, and 8. Good.
Is that like a shortcut?
Kind of a shortcut. Yeah, you don't have to do it for
I
everyone.
just realized this.
Yeah, because it's the same each time. And so if those 4 are my answers, Elijah, if I said this is not from 0 to 2 pi, I want you just to, it's all answers, right? You'd have to add something to each of those values. Do you know what you would have to add to each value? 2 pi n normally, right? But the period changed here, didn't it not? Because what is period? It's 2 pi over b, right?
Yeah,
What is b?
B is sine. I can't see.
It's that 2 that's with x, right? Hey y'all, if we could come in, let's make sure phones are up. That's 5 minutes there. Let's get it going. So what would you do?
2 pi over what you were pointing at.
It's the number that's with x, right?
Yeah.
Traditionally it's 1, now it's 2. So 2 pi over 2 would get me
Pi.
pi. Good. So the new period is pi. Mhm. So what would I add to each of them? Pi times. All of them would be pi times n, and I would do it for each of these, right? Pi n. Pi n.
Would we just leave it as pi?
What's that?
Would we just leave it as pi?